बस 1 मिनट में स्टार्ट करें।
Sir,
जी
can you explain how to draw optical isomers?
नहीं, how to 1 second. ठीक है, how to draw optical isomers.
Yeah, which side will be at the top? Which one will have like the
अच्छा, so
triangle?
I'll just briefly go through that. That if you have a I said, remember we're going to try and do this paper. ये मैं बस explain कर रहा हूँ कि if you have a chiral center, firstly, it doesn't really matter which side is the one at the top. So, for example, if I have this molecule and they say that it's got a CH3 on one side, it's got an H on one side, and it's got, let's say, an OH on one side, right? So it doesn't really matter which side is what. For the only thing is that it should be, you should draw, if they ask you to represent the three-dimensional diagram, you should draw a tetrahedral structure. And once on one side there's a Cl. You can put it anywhere. Okay? On one side you got an H. On one side you have an OH. Make sure read the question carefully. Are they looking for a displayed formula? If it's a fully displayed formula, then you have to draw all the bonds. I mean, instead of writing CH3, you should write C with 3 H's. But if it's not, then you should only just draw the 4 bonds like this, and you can condense the rest of the structure. But it doesn't really matter. But once you're drawing the other one, the mirrored version is just going to be an exact mirror of this. So the first one, the orientation of the bonds could be anywhere. Anyone could be on the top, on the right side or the left side. That doesn't really matter. But when you draw the other one, which is the mirrored version, then everything has to be mirrored correctly. So, so plus, although there hasn't really been a specific question on this, at least in AS, but remember the mirrored version can, it's not always that the mirrored version orientation is always the same. I mean, you should be able to, like, if you have your two hands, right? You have your left hand and your right hand. I mean, if you just keep it straight on the table, then they're obviously mirrored version. But if you just rotate one of your hands, then it doesn't really look mirrored, right? So remember this other one, although there hasn't been any question on this, but this other one could be rotated in a different way. And you should be able to spot that. So for example, what I can have is, I can have a molecule which is not exactly, I hope you're getting my point. Like if you have your two hands on the table, they're obviously mirrored versions of each other. It's like if they're put straight on the table, right? If they're put on exactly, but if you rotate one of the hands, then it's obviously not a mirrored version, but it is still the same hand, right? If your left hand and your right hand. So the other version can be sort of a rotated version as well. So maybe you have this molecule and they might give you another one which is not mirrored in the conventional sense, like you putting things like in this sense. It's not mirrored in this sense. But you've got instead of Cl over here, you got a CH3 on this side, and you got a Cl on this side. Now this one is not mirrored in the conventional sense, the way you're used to drawing, but that one is still a mirrored version because two of the bonds are in the same orientation, but two of the bonds are in a different orientation. So you should spot the difference in orientation, that this carbon atom, it has a certain orientation, but that one over here has a completely different orientation, that two of the bonds are in exactly the same orientation, but two of the other bonds, the Cl, instead of going to the left, it's actually coming out of the page. So that one is also, I mean, these two are exactly the same. It's hard to spot, but make sure that you're able to figure out that in a tetrahedral arrangement, you're able to figure out that the bonds are oriented in a different way. And in the mirrored version, uh, two of the bonds would always be in the same direction. Like even in this case, the H is at the top, the H is at the top, and the CST is coming out of the page, the CST is coming towards you, right? So two of the bonds are in the same orientation, two of the bonds are in different orientation. The OH is on the right side, the OH over here is on the left side. You can apply the same logic to this one. That one is also a mirrored version, that two of the bonds, the H and the OH, are in the same exact orientation, but two of the other bonds are in a different orientation. So do you get the point that it should, the enantiomer or the optical isomer, it's not supposed to be exactly mirrored like you're seeing things in a mirror, right? The other one could be a rotated version. So I mean, these two are exactly the same. It's just a rotated version. You pick that up and you rotate it or flip it around in some other way. So it looks different, but it's kind of exactly the same. Is this point clear?
Yes.
So, but they haven't asked any in A2. They've asked this, but in AS, they've not given any question on that on this. Most of the time, you just have to draw just a mirrored version of this. But just make sure, keep this in mind. That's going to be a lot harder to actually figure out. Questions in A2 related to this are kind of like this, that they'll give you 2-3 molecules and they'll ask you to spot the mirrored version. So the one in which two of the bonds will have the same orientation and two of them will have different orientation, that's your mirrored version. As anyway, starting with this question, we've got draw a curve on the axis to show the Boltzmann distribution of energy of particles in a sample of gaseous krypton atoms at a given temperature. So that's a Boltzmann distribution. So it's going to be skewed on one side, and one axis would be energy of particles, and the other one would be the number of particles or the proportion of particles or the percentage of particles. Then you have to draw a second curve to show the distribution of energies of the krypton at a higher temperature. So at a higher temperature, at higher energies, the number of particles would increase. So it's going to become higher on one side and lower on the other side. So it's going to become flatter as well. So that's the one with higher temperature, which is T2 in this case. The first one was T1. The two assumptions of the kinetic theory as applied to an ideal gas. What are the two assumptions? The two main assumptions.
The volume of particles of a gas are negligible compared to the volume of the gas itself.
Okay, so one is volume of particles is negligible compared to the volume that's occupied by the gas. So compared to volume, what's the other one?
All collisions are elastic.
No, that's not the main assumption. You can remember the main assumption. There are two main assumptions. What's the second main assumption?
Particles have no
attraction between molecules.
Okay, so there's negligible intermolecular forces. Remember, there are lots of assumptions, but the two main assumptions are negligible intermolecular forces. So, and what are the other assumptions if somebody asks, if it's a 5-mark question, they ask you for more than two assumptions? One was collisions were elastic. What else? I mean, there are lots of other assumptions. Temperature is basically proportional to the average kinetic, or temperature is a measure of the kinetic energy of the particles. Then you also have an assumption that you've got another assumption, which is that they behave as rigid spheres. 1 second. So gases behave as rigid spheres. So that's another assumption, and any other one. There's one about pressure as well. That pressure. What causes pressure? Pressure is due to collisions of the gas particles with the walls of the container. And that should be enough with container walls. But remember, always go for these two. Those are the two main assumptions. What happens? Sticking to this, let's explore this further. What happens if how is a gas affected, or what happens? What goes wrong if a gas has intermolecular forces? Like, what values in the ideal gas equation will be affected? Like, I'm going to come back to if I have PV is equal to nRT, that's my ideal gas equation. So what if you have intermolecular forces? What value would be incorrect in this equation?
Volume?
The main thing that's going to be affected is going to be pressure, because if a gas has intermolecular forces, what will happen is that the gas particles previously were freely moving around, right? I mean, the volume is fixed. The volume is the container volume. The volume never changes. I mean, if there's a fixed container, so the assumption is the volume is never going to change. It's going to be the same volume, right? The volume, if it's a fixed container, if it's an elastic container that like a balloon that can expand and contract, then obviously volume would be a factor. But let's assume that it's a fixed container and the volume is not changing. So what happens is that gases are freely moving around, but if the gas particles, they start to attract each other strongly, what will happen is that they will slow down each other. I mean, this particle is traveling in the other direction, so the other particles would be pulling it back. And if it pulls this part, if this particle gets pulled backwards in this, I mean, if these particles are pulling it backwards, the particle would slow down as it reaches the walls of the container. And as it slows down, less pressure would be exerted. So the pressure exerted, the real pressure would actually come out to be less compared to the equation pressure. So there's going to be error in this. I mean, the equation would be telling you that you're going to get 1000 pascals, but in reality, you would just be getting like 700 pascals because the particles are slowing down and it's not hitting the walls of the container with the same exact force. Is that clear?
Yes.
And what about the first one? If the gas particles, first thing, if the gas particle, let's stick to the point number 2 first, intermolecular forces. So under what conditions would the intermolecular forces be negligible? Like, what conditions would you use?
High temperature, low pressure.
You're
Low
going to
pressure.
use high temperature and you're going to use low pressure. Both would enable that the intermolecular forces remain negligible. Why? Because high temperature, the particles would be so energetic that the attractive forces would be easily overcome and broken. At low pressure, the intermolecular forces are also negligible, because at low pressure, the particles would be so far away from each other that low pressure ka ye matlab hota hai ki the particles are really far away from each other. The large gaps. When you have low pressure, the volume increases. So particles would be so far away from each other that they won't even attract each other. So in both cases, the intermolecular forces would become actually negligible. Acha, what about the first one? How does the ideal gas equation go wrong when the volume of the particles is no longer? First thing, pehle to batao ki under what conditions does the volume of the particles no longer is negligible? किस condition में the particles are no longer negligible?
High pressure and low temperature.
ठीक है, so basically what happens is that it's got nothing to do with temperature. ठीक है. This one becomes negligible at high pressures. As long as the temperature will not, as long as it's a gas, the temperature would not be a factor. So what happens is that particles are far away. As long as there are large gaps between the particles, the gas is compressible. Pressure and volume are inversely proportional. So what you derive from the equation is that pressure is inversely proportional to volume. So as long as you increase pressure, the volume should decrease. So, but what happens when you take it to a high pressure? The gas, it starts to compress. And as it starts to compress, there would be fewer and fewer gaps between the gas particles. And there would come a point when the gas would no longer be compressible. So if you increase pressure, the volume will not decrease. And this relationship would fail. You continue to increase pressure, the gas is no longer compressible. So at high pressure, this statement will no longer be true. And the equation will not work. Pressure would not be inversely proportional to volume. The gas would become incompressible because it's running out of gaps. So moving on, next one, you've got a simple question, which is that you have to apply PV to nRT, and we're going to do that. And we have to assume krypton behaves as an ideal gas, calculate the pressure in pascals. How do you calculate pressure? Pressure is PV nRT, so it's moles. How many moles do you have? That's 2 grams divided by what is the AR of krypton? 36. 1 second. I mean, bromine is 30. It's not. It's 36 actually, but that's the atomic number, not the atomic weight.
83.8, sir.
Was 83.8 after 83.8 later. I mean, use the one that's given in the data booklet, so it's 83.8, right? And RT, that's 8.31. So, what temperature should I use? 120 degrees centigrade is given over here.
Kelvin.
393.
Plus 273.
So 393 degrees should be in kelvins. That's nRT and divide by V. So 5 dm cube. What value should I use?
5 over 1,000.
That's going to be 5 over 1,000 or 5 into 10 to minus 3. So tell me what the answer to this is.
So I got 15,600 to 3 significant figures.
15,500.
600, 500.
15,600. 3 significant figures.
600.
Okay. Pressure pascals, man. That's pascals, right? So
Yes, sir.
it's 15,600 pascals. These values were accurate up till 3 significant figures. So your answer should be at least up till 3 significant figures. State and explain the conditions at which krypton behaves most like an ideal gas. We kind of did that. Negligible intermolecular forces. So condition would be high temperature and low pressure. And you can say that at high temperatures, you have to explain this. They've given you plenty of lines. So molecules have kinetic energy and they can break the intermolecular forces, and that's why the intermolecular forces would be negligible. Low pressure, the volume of the particles would be negligible compared to the volume occupied by the gas because there's going to be large gaps. So then I have this question, which is simply just O levels. It's you got an endothermic reaction. So your product is going to be so your product is going to be higher. It's gaining energy. The activation energy is 385, or all arrows must start from the reactant. So that's 385, and the enthalpy change would be going from the reactants to the products. That's plus 60.2, and you can label this. This is EA, and this one is delta H.
Sir, do you need to write the numerical values?
I mean, you can't take the risk. Like, I mean, it's better to write as much as possible, right?
Okay.
Okay, so the next one, explain in terms of actuation energy, the collision of particles have an increase in temperature affects the rate of a chemical reaction. So if you have a higher temperature, it's going to have particles have more kinetic energy. Which means more particles will have energy that is greater than. So the number of particles having energy that is greater than activation energy is going to be higher. And that is why not only the frequency, but the effectiveness, frequency, and so particles traveling faster would bump into each other a lot more, but particles being more energetic would make the collisions more effective as well. So frequency and effectiveness of collisions increase. So how is Cl2 used in water purification? What does it do exactly? It's just a 1-mark question.
Kills the bacteria in the water.
Okay, so disinfectant kills bacteria. That's the next one. Chlorine has the highest first ionization energy of the period C elements Na2Cl. Construct an equation for the first. So it's just you're just removing one electron first ionization energy, and it will become +1. Gaseous. Remember to write the state. Explain the general increase. So what happens? This is how across the period ionization energies look like. So why does it increase across the period? Yes, Hamza.
So for the chlorine used in water question, is it fine if we write the equation for how it disinfects it?
That's not part of your syllabus actually, like how it I mean you can write the equation like Cl2 reacting with water and it produces HCl and HOCl. But the that part is not really in your course. I think the question more about what's more important about this question is that it's asking you to figure out what does it do in water purification. I mean, there are lots of processes. So what does it exactly do?
Got it. Okay.
Okay. I mean, you can write the equation and make sure. I mean, as long as the equation is correct, right? It's just a 1-mark question, so that's why you went for that. But just to be on the safe side, you should write the equation.
Okay.
I say, jaldi se bata do, why do ionization energies increase across the period?
Nuclear charge increases.
Okay, so two more factors. I mean, that's the main one. Nuclear charge increases, right? What are the other two factors?
Atomic radius decreases.
The attraction of electrons nucleus also increases.
I think वो तो end में लिखेंगे. What's more important is that the shielding remains constant, or you have the same number of shells. And because of all of this, the atomic radius also gradually decreases. I mean, this one probably doesn't carry any mark in the marking scheme. So you're going to write that because of this and the last statement. Make sure you write the last statement. So because of these factors, the nucleus attracts electrons more strongly. Make sure you write the statement at the end. We've got thermal stabilities. State and explain the relative. So who's more stable, HCl or HBr or HI?
HCl.
HCl is more stable and HI is the least stable. You can write proper statements like this is least stable, that one is That one is more stable. And why? I mean, we stated it. Now we need to explain that. That's the other mark. So why is HCl stable?
It has unstable charges and the bond length is even less, so it's hard to pick.
Mainly the way it's bond
Charges
energy.
are undistributed.
The charges, they're all polar. Okay? They're all covalent molecules. The main factor is that HCl has a stronger bond. So it's got a higher bond energy. It's hard to break the bond. And why does it have a higher bond energy? Because smaller atoms, they always make stronger bonds. Why do smaller atoms make stronger bonds? Because smaller atoms are less shielded, so they attract each other's electrons more strongly. So there's more orbital overlap, and there's a shorter bond length. And what happens down the group? The bond length increases. And iodine is a big atom. Shielding also increases. So iodine is going to be less attracted in some other atom's electron because its nucleus is already surrounded by 53 or so electrons. As if next is you've got the oxidation number of sulfur. So the main sulfur containing product of each reaction is shown in the table. So that's easy. What's the oxidation state of sulfur over here in this molecule?
+6.
Yeah, that's +6. I mean, you can do that. That's H is +1, sulfur is X. Oxygen is -2 times 4, and the total charge is equal to -1. So you solve this, it's going to come out to be +6. Sulfur over here is +4, and over here it's -2. Complete the table. Explain why different sulfur-containing products are produced when each of these halides ion react with concentrated sulfuric acid. So what is happening to sulfur? Sulfur goes from +6. In the first one, you don't have a redox. In the second one, you have a reduction of sulfur. In the third one, you have even greater reduction of sulfur. Sulfur goes from +6 to -2. So why is, it's just 1 mark. So why is sulfur getting reduced by iodine or iodide?
Because it is a strong oxidizing agent. Sorry,
Okay, so
reducing.
reducing agent. Okay, so reducing power increases. Because I-1 really likes to lose electrons. Why does it like to lose electrons? Because it's got a much bigger, it's got too many shells, so it easily loses electrons. It's got 54 electrons. So because of that, it easily loses electrons, which is why it easily gets oxidized, and it's a very good reducing agent. So reducing power increases. So ये जो electron lose कर रहा है ना, sulfur has to then gain those electrons, and which is why sulfur goes to -2. But anyways, reducing power increases, and because of that, you will have it's just 1 mark. So down the group, if it had been a 2 mark question, and so then you would have to explain further a bit that what happens down the group. Shielding and distance or the atomic radius of the ionic radius in this case. So the ionic radius, that is definitely not required in this one, but shielding ionic radius increases. So it's easier to lose electrons. It's easier to get oxidized. So what is meant by the term disproportionation? What is disproportionation?
Same element gets moved to oxidized and reduced.
Okay, so the same element gets oxidized and reduced. And you have to remember 2 equations, one with Cl2 with cold NaOH. What's the equation of Cl2 with cold NaOH?
NaCl and
It-
NaClO plus water.
Okay, so you're gonna get NaClO plus water. If they had talked about hot anyway, फिर क्या होता?
NaClO3.
Okay, then it would have been NaCl and NaCl. As a pehli wali balance karna, that's easy. Okay, you just have to put 2 over there and it gets balanced. Plus H2O. This second one, if I mean in this question they haven't asked for this one, but if they had asked for the second one, this one is a lot harder to actually balance. Does anyone know how this equation gets balanced? It's not going to get balanced the conventional way, by the way. It would help you to actually remember the balancing for this, but does anyone know what the balancing is for this one?
3, 6, 5, 1, 3.
Okay, well, 3Cl to 5 NaOH, sorry, 6 NaOH. 5 NaCls, 1 NaClO3 and 3 H2Os. Achha, but remember, I'll just recap. How do you balance the redox equation? You just quickly balance the number of electrons that are gained and lost. Cl is 0 over here, Cl is -1, so that means it gains how many electrons? It gains 1 electron. And Cl goes from 0 to +5 as well. So that means it lost 5 electrons. So the electrons gain and loss, they got to be equal, and to make them equal, I'm going to multiply this by 5 and I'm going to multiply this by 1. So that means I should have 5 Cls that should be turning into 5 Cl minus 1s. And I should have 1 Cl that should be turning into Cl plus 5. So there should be 1 of this. So that's a total of 6 Cls at the start. 5 of them turning into Cl minus 1 and 1 of them turning into plus 5. And then you can balance the rest of the equation. It's 6 NAs. So that's going to be 6 Na and 6 Hs, so 3 H2Os. So make sure how to quickly balance the electrons that are gained and lost. Redox equations are always going to be balanced that way. I see, you've got, they're just saying draw a diagram. They haven't told you which diagram actually, but just a diagram to show all the types of bonds. So the diagram is about drawing the types of bonds. You have to draw Al2Cl6. So Al2Cl6 is a dimer. The normal molecule is AlCl3. Al has an incomplete octet. It's got 6 electrons. So there is space available. And Cl has lots of lone pairs. So there's going to be another AlCl3 molecule. And that Al also has room available. So it's going to attract electrons and it would form a dative bond. The lone pairs of this Cl will get attracted. So they would end up forming dative bonds as well in the middle. And you can label all the bonds. You can talk about this being a dative coordinate bond or just a coordinate bond. And the other ones being normal covalent bonds. You can label them as well. So आगे चलते हैं. What would you see when solid aluminum chloride reacts with water? What type of reaction occurs? So what happens when you mix aluminum chloride with water? And tell me the detailed reaction. What happens when you mix it with water? Does anyone know what's the equation?
Al2O3.
Okay, you can write Al2O3 and the other one?
HCl.
Okay, that's the overall reaction. But remember, the recent market scheme is looking for the detailed one, which is I did send you the notes for this. It's वो यहाँ पे दिखा देता हूँ. What's the detailed reaction? Does anyone know what the detailed reaction is? It's a 2-step reaction. It's this one, that it first forms a complex, which is I think it's given over here. So the first step is that aluminium reacts with water. I'm sharing this again. Make sure I'm sending the link over here. ठीक है, इसके मेन तो ये concise notes हैं, but you would have to. I mean, these are further explanations for the same notes. So first thing, I'll just quickly tell that. I mean, that is fine. Aluminum oxide, hydroxide are the same thing. You get a solid and you form HCl aqueous, a strongly acidic solution. But the detailed reaction is, the first step is that aluminum chloride, which is soluble, it mixes with water and ends up forming this complex, which is AlOH3. Sorry, it ends up forming AlH2O6. That's the complex that is formed. So the first reaction that you're going to write is, you're going to break this into two steps. So initially, AlCl3 mixes with water, 6 water molecules, and 6 water molecules that surround the aluminum ions, forming a complex with a +3 charge. And the 3 Cl ions, they become aqueous. And in the next step, the aluminum has a very strong positive charge. So this part over here. So the aluminum has a very strong positive charge. So what it does is it polarizes the water molecule, and the water molecule, the positive H of the water molecule, they start getting knocked out. They start getting repelled. So the aluminum ions are attracting the OH, which is -1, but not attracting the H positive. So the H positive gets knocked out. So in the next step, you have aluminum hydroxide forming. And 3H+1, so you end up getting a very acidic solution. So name the type of reaction. All these reactions are known as hydrolysis. I'll also consult the Marx name because it's the previous ones, the older ones have this overall equation, which is fine as well, because but the new ones have the reaction split into two, because the HCl is formed in this way, that the first reaction produces Cl ions and the next one produces the H+1 ions. So the solution has HCl, which is aqueous. And you also have aluminum hydroxide, which is kind of the same thing as aluminum oxide. So it's better to go with the more detailed reaction, which is this one. Anyways, the whole question was, it wasn't even about the equations. You just had to name the type of reaction, that is hydrolysis. And what you would see in this reaction, you'll see a white precipitate that would form, and you will see fumes of HCl gas that are going to be formed as well. So these are the two things that you're going to see in this question. Is that clear? So there was no need for these equations. And also just a quick recap about this. Hydrolysis of chlorides, it's very important. You have NaCl. That just mixes with water, nothing happens. It just dissociates and it forms a neutral solution. MgCl2, slight hydrolysis happens. Mg ions, they also mix in water, but they slightly repel the H positive ions. So some H+1 ions are produced, which makes the solution very, very slightly acidic. But MgCl2 mostly dissolves. It just forms a pH which is almost neutral, but not exactly neutral because of the slight hydrolysis. And then you start getting stronger hydrolysis. AlCl3, SSCl4, PCl3, and 5, they all have vigorous reactions. So let's move forward. In this question, you've got 0.02 moles of element Z reacts with an excess of Cl2 to form 0.02 moles of. So starting, the first line, it's Z reacting with Cl2, and it's forming what, some chloride, which I have no idea. So it's ZClX, let's say. They've actually given it as ZClN. So this is given that this is 0.02 moles. and this is also 0.02 moles, while this one is in excess. अच्छा फिर क्या है कि ZClN reacts with water at room temperature to give an acidic solution and a white solid. So it reacts with water, and when excess silver nitrate is added, this solution 11.5 grams of AgCl is formed. So basically, whatever is happening, we don't know what the reaction is because we don't know what Z is. I don't know how it's going to react with water, but what is happening is that the Cl lines when ZClN reacts with water, all of them, they turn into, eventually at the end of it, turn into AgCl. And it's 11.54 grams. So the assumption is that all the Cl lines are coming from this thing. So first thing is, how many moles of AgCl do you have? The pehla cheez hai is you'll find the moles divided by the MR. What is silver? That's 108, I guess. You could bata de ki what are the moles that we're getting?
.08.
So we're getting 0.08 moles. So that's one AgCl has one Cl line. So that means 0.08 moles will have 0.08 moles of Cl lines. So I know exactly how many Cl lines are in the solution. So I'll focus on this one and I'll figure out what N is. So 0.08 moles of this molecule are producing 0.08 moles of Cl lines, right? If I simplify this, ZClN 0.02 moles are producing how many Cl lines? They're producing 0.08 moles of. Okay, because one AgCl has one Cl line, so 0.08 moles will have 0.08 moles of Cl line. So I know that all that Cl line is coming from here. So 0.02 are producing 0.08. So that means what is the ratio? It's 1:4. So that means one ZClN will produce 4 Cl lines. So what is the value of N in this case? कि एक में से ना 4 produce हो रहे हैं. So that one will contain how many? That's going to be, N will have a value of 4, right? Is that clear?
Yes.
So we are able to calculate the value of N, which is 4. Okay, एक molecule में से ना there are 4 Cl lines that are getting produced. So that one molecule has 4 Cl lines. That's why it's getting produced. Suggest the type. So that's 4. The next part, and always remember, answer this question. I mean, make sure you show you're working properly. I mean, this is still very rough, but make sure you do a neater version of this working. 1 mark at least is for just the working. So what about the type of bonding and structure? It's a liquid chloride. So a liquid chloride means that it's got a low boiling point. So what type of structure and bonding and structure, you have to describe both things. What type of bonding does this have?
Covalent.
Okay, so the bonding is covalent, and what type of covalent structure?
Tetrahedral.
Any simple molecular. Okay, structure, they're talking about structure in terms of bonding. Okay, so it's simple molecular because there are 2 types of covalent structures. One is giant, and that's not going to be a liquid. Okay, the other one is, and based on your knowledge about, if they haven't asked you, but if they had asked you to identify a Z, what is Z in period 3? Like, which of your chlorides is a liquid? Which one has a formula of ZCl4?
Silicon.
Yeah, that's silicon. Silicon chloride. Remember, SiCl4 is a colorless liquid. These two are ionic. NaCl and MgCl2 are salts, white salts. PClCb is a colorless liquid, but it's got 3 Cls. Now moving to the next one, we've got free radical substitution. That's the first thing. That's the only mechanism that you know of. That's free radical. Substitution. What are the essential conditions required for this?
Sunlight.
UV light.
ठीक है, sunlight से बेहतर UV light होता है, ठीक है. ये when in doubt दोनों ही लिख दो, because sunlight has UV light actually. Now give the electronic configuration of the Cl radical. How is a Cl radical different from a Cl atom?
One less
Yes.
electron.
Okay, I've got Cl which is 17 and 35. So just remember the Cl radical is the Cl atom. Okay. Radical, putting a dot makes no difference whatsoever. Like if I put oxygen and then I put a dot over here, that's the same thing as oxygen, right? Is that clear?
Yes.
So what the term radical refers to is an odd number of electrons. That the Cl atom has unpaired electrons. It's got 7 electrons in its outer shell. So that's why you put a dot on it, because it's a radical. वो जो electrons कम या ज़्यादा होते हैं ना, that happens because of the charges, if it's -1 or +1. Putting a dot on top will make no difference to the electronic configuration. It's still Cl, right? So it's going to be 17 electrons, 1s2, 2s2, 2p6, 3s2, and 3p5. So that's why you're putting a dot on it. It's a radical. It's unpaired electrons. And these species are very reactive. Why? Because they want to complete their bonds. Identify the products labeled. So this is a propagation step. What happens in a propagation step? What are the products? Okay, the carbon is a radical.
The radical of the halogen and here, right here.
नहीं, इस पे होगा कि, remember in the first step, Cl radicals are produced, right? So I'll explain. Propagation is the Cl radical has incomplete bonds. It's a Cl atom basically. It's got incomplete bonds. So what it will do is it's going to attack this whatever the organic compound is, and it's going to steal the hydrogen from it. So it takes away one hydrogen from it, and they end up forming HCl, right? So the carbon is now not having complete bonds. It's got 3 bonds now. So the carbon is now a radical. Is that point clear? So propagation में होता ये कि when the radicals are produced, the radicals, they start attacking the molecule and they start stealing atoms from the molecule. So the H is taken away, HCl is formed, and carbon radical is produced. And then you have another radical that's produced. You got another radical. That radical would do the same thing. It sees the Cl2 molecule, it attacks it. इस carbon को एक bond चाहिए ना, it needs an atom to bond with. So it will steal the Cl from that chlorine molecule. तो क्या बनेगा? It's going to be CH2 and Cl2. Carbon के bonds पूरे हो जाएंगे, ठीक है? So it's no longer going to be a radical. But then a Cl radical will be produced. So those are going to be my products. So the Cl radical is again formed. Or propagation इसी तरह चलता रहेगा. One of them is a radical. It attacks the other molecule and tries to steal atoms from it. That results in the creation of another radical. That radical then goes and attacks another molecule, tries to steal atoms from it so it can bond with it. And another radical is produced and just keeps on going. So अब ये पता नहीं कि उन्होंने, are they asking you to name this? This one is dichloromethane. Or you can just write it. Name the type of reaction. What is the final step known as?
Termination.
Yeah, that's your termination step. So somewhere in the middle, when the atoms and the radicals are all fighting over electrons, this radical attacks this one. They're fighting over atoms. Somewhere in the middle, 2 radicals, they both need electrons. They both need atoms to bond with. They'll just directly bond with each other, and that will end the reaction. That will finish the radicals. So that is termination. Suggest the identity of another organic molecule that is a product of the reaction under the same conditions. So any other possible organic product that could be produced in the final step.
Yes.
Hmm?
Yes.
नहीं मुझे समझ आया क्या कह रहे हो?
I think, yeah, there could be other products. If you include.
I mean, there could be many other products actually. It's like, I mean, the propagation step will continue. There might be another Cl radical and that would steal another H. So the number of Cls can vary. Here, that's one thing you could make. You can turn this into CHCl3 as well. The number of chlorines. CH2Cl2 तो हो गया ना. Sorry, CH2CH2. That's not going to be. I mean, that's not going to happen because that's the first. I mean, that's the original. I don't think there's a CH2 radical that's being produced anywhere.
2Cl2 radicals to form Cl2.
हाँ, लेकिन you're not going to write that because it's an organic. I mean, they're looking for an organic product. ठीक है. अच्छा, but anyways, it could be. अगर मैं इसका करूँ ना, let me. We had this radical, right? We had this. देख लूँ पहले कौन सा था, CH2Cl radical, right? So the carbon has incomplete bond. So what can happen is, okay, two of these can get together, right? Yeah, if I draw the whole thing, the carbon has at the moment incomplete bonds. It's a radical. There's another one which is identical. And they would get together, right? And they would form this molecule, which is going to be CH2Cl and CH2Cl. Or lots of other combinations. You could just change the number of Cls. You could, I mean, CHCl3 could be a product because the Cls will continue to substitute in every propagation step. You could have CCl4 as the product as well. The number of Cs would kind of remain constant. The hydrogens will continue to get displaced. Is this clear?
No, sir, could you explain again, please?
तो फिर मैं सारी बनाता हूँ कि सारे propagation Cl radicals produce हो गए ना, right? So I don't know what the starting point was. What was the starting point? I said the starting point was CHCl3, right? So let's start with, now I'm drawing propagation steps, right? So starting point
Yes, sir.
was CH3Cl. First propagation step. The Cl radical comes in, takes away the H. It forms HCl, right? What is left is C with two H's and a Cl. And that's now a radical because its bonds are incomplete, right? Then this radical, the C with two H's and one Cl, it then attacks a chlorine molecule. So there's a Cl2 molecule and it steals one of the Cl atoms and bonds with it. So what do you get? You get CH with two Cls now and another Cl radical is produced. Okay. ये clear है यहाँ तक?
Yes, sir.
Actually, now the propagation step will not end. It just goes on randomly. So you got another Cl radical. What will that do? That will try and grab one of the hydrogen atoms over here. So if I continue further, it's going to be, I've got CH2 and two Cls. And here's another Cl radical that's coming in. It needs electrons. So it steals one of the hydrogens over here, right? So your molecule becomes a radical once again. And HCl is produced. And then again, the same thing. It's now your molecule is the radical. So it attacks a chlorine molecule and grabs one of the chlorine atoms and bonds with it. So it's got now three Cls attached to it with one H. And another Cl radical is produced. Now this other Cl radical would do one more propagation step. It will go and try to steal the H over here, right? So the Cl radical would go on another mission to steal one of the hydrogens. तो उससे क्या होगा कि वो H चला जाएगा, NaCl would be formed again, right? And you will have CCl3 radical. वो जो CCl3 का radical होगा वो फिर end में it will attack the chlorine molecule again, and eventually it will become, मतलब उसका radical जो है वो खत्म हो जाएगा, that will finish, but again a Cl radical would be produced, right? So I've drawn all the propagation step. Is the propagation clear? What's happening in the
Yes, sir.
propagation? Now the last step is, so the first thing is, you could get a carbon with 4 Cls, you could get a carbon with 3 Cls, you could get a carbon with 2 Cls as well, right? Or the starting point was the carbon with 1 Cl. So the number of Cls will continue to add up, right? And the termination step is the final step, the termination step. That's when any of the 2 random radicals that are produced, any of them. Like I have a CH-Cl3 radical, right? And I have a CH2Cl radical. So this carbon needs a bond, this carbon needs a bond. Why don't they just bond with each other? That's so that's my termination step, that I got 2 H's, I got 1 Cl, and on the other side I've got 3 Cls. So they might, that's a termination step. Is that clear?
Where did the other carbon come from?
I mean, this one, like you had this radical and you had this other radical. Pura reaction mein ek molecule thodi hai. I mean, there would be lots of propagation steps happening, right? So someone would be
Okay.
producing this radical, some other one would be producing this radical. So why don't they just get together? Because sara masla ye hai ki this needs 1 bond, that needs 1 bond. So instead of this attacking a chlorine molecule to steal an atom, and this attacking in the next step another chlorine molecule to steal a chlorine atom, why don't they just attack each other? Like this one is looking for 1 electron, this one is also looking for 1 extra bond, covalent bond. So why don't they just share electrons with each other? So that's termination. Is that clear?
Yes, sir, that's clear. And sir, another question. The last propagation step you've drawn with the 4 Cls, can't the Cl attack another
there's no
Cl2?
force. I just say there's force. Yeah, kya keh rahe ho?
Couldn't the Cl attack another Cl and become Cl2?
But
Yeah, ऐसा नहीं हो सकता.
that's not, you can't call it termination of propagation, because you're starting right at the, that will happen. लेकिन वो तो वही हो गया ना कि you're again back to the reactants. So you're looking at the reverse reaction.
Right. Okay.
ठीक है, तो जब भी आप reaction लिखते हो ना, you write a reaction to make new things. तो अगर Cl2 से start किया वापस end में you're making Cl2 back again, so that is not a reaction basically. You just ended at the same point where you started.
Yes, sir.
So ये वाला enthalpy change in the formation of CO2 is so what's the formula that's going to be used over here? They're asking you to calculate the enthalpy change of formation of P, which is this one. And they've given us the enthalpy of formation of CO2 as well. So how would you figure out the enthalpy of formation of, I mean, this is the one that you're looking for. तो क्या करोगे इसमें?
Use versus law.
Do you draw a Hess cycle or do you use a formula? You're going to use the formula, which is that the enthalpy change, which is already calculated, that if you know the enthalpy of formation of the reactants and the product as well. Achha, how do I know the enthalpy of formation of O2? What's the enthalpy of formation of O2?
It's not required.
0.
ठीक है, मतलब 0 है basically, not required. ठीक है. Elements are formed from elements, so that's 0. And this is also 0. So you're going to use products minus reactants. The enthalpy change is going to be, the formula is that if you know the enthalpy of formation of the reactants and the products, so that's your formula. Be careful with the sign. So the sign is product is 4 CO2. So that's 4 into minus 384. The other one is 0. Okay, make sure you use brackets, and then the other one is C4 into that's the unknown, that's X. 402s, that's 0. And the overall enthalpy change is minus 2036. So can anyone tell me what the answer for this is?
500.
Okay, exact 500.
Yes, sir.
So I said that one is 500. One of the products of the complete combustion of PE is nitrogen gas. Explain the lack of reactivity. So give me two reasons. I mean, they're asking for one reason. Give me two reasons why nitrogen gas is inert.
It has strong triple covalent bonds.
ठीक है, तो एक तो ये हो गया. That's strong, very strong triple bond. High bond energy. ठीक है. And the other one is no dipole. It's non-polar. So it's non-polar, which is why it doesn't really attract anything or attracted to anything. Explain what is meant by the term Bronsted-Lowry acid. Two things. I mean, what's a Bronsted-Lowry acid? And what is weak?
There's a proton,
An acid is a proton donor.
and it's partially dissociated H positive ion.
ठीक है, तो weakly ionizes or partially ionizes? So a weak acid is one that partially ionizes and is a proton donor. I'd say is ethyne and all triple bonds between two atoms. A triple bond consists of one sigma and two pi bonds. Draw a label diagram to show the formation of one pi bond. किसमें ethyne की बात कर रहा है? That's in HCN, right? You've got HCN. That's H with C with triple bond N, right? So when you just have to draw a pi bond, it's going to be TK, and they just want to show you one pi bond, right? So it's a sideways overlap of orbital, and you're going to tell them. I mean, you can shade this. So that's it. That's your pi bond. इस केस में बताओ, how many pi bonds do you have in total?
One.
You've got
Two.
two. Okay, the first bond is always a sigma bond. The rest are all pi bonds. So this one has two pi bonds. What is the hybridization of carbon in this case?
SP3.
That's sp3 is when carbon is making
SP2.
sp2 भी नहीं है.
P.
SP only.
SP.
sp3 होता है when carbon is making 4 bonds for tetrahedral, and all 4 electrons are involved in making sigma bonds. Okay, they're all getting stretched in different directions. sp2 is when carbon makes 1 pi bond. How does it make 1 pi bond? Because it's only bonded to 3 atoms. So it's bonded in a trigonal planar arrangement. And the 4th electron, wo farak pada hua hai, that is not doing anything. So that 4th electron makes a double bond. And sp is when carbon is only bonded to 2 atoms usually. So like 2 oxygen atoms in carbon dioxide. In that case, 2 of its electrons are now available for pi bonding. One on the y-axis, one of them will be on the z-axis. So both of them would be involved in. So this is sp, carbon making 2 bonds. So whenever you see 2 pi bonds, the easy way to remember this is because this can also come for oxygen and nitrogen. When something makes 2 pi bonds, that's sp. When something makes 1 pi bond, that's sp2. And when it's not making any pi bond, that's sp3. Same thing applies to nitrogen. Same thing applies to oxygen as well. इसका मुझे जल्दी से बता दो कि if I have an oxygen molecule, right, like water, tell me what the hybridization is based on what I just told you.
SP.
You count the number of pi bonds. So मतलब ये मैं यहाँ पे फिर से clear कर देता हूँ कि I mean you do get questions on carbon but not that frequently on oxygen or nitrogen. So ठीक है, it's going to be sp3. So let me explain this again. कि no pi bonds, इसका मतलब है there's no electron left to form a pi bond, right? So that's sp3. One pi bond, so that's sp2. And if it's making two pi bonds, then that one is sp. So in this case, it's not making any pi bond because for a pi bond you need a double bond, right? So no pi bond. So it's this one is going to be sp3. Okay. What about an oxygen making a double bond? What type of hybridization is this?
sp2.
sp2.
Okay, one pi bond, so that's sp2. If I have, what about nitrogen over here? What type of hybridization is nitrogen having?
sp3.
It's making two pi bonds, so it's sp. Okay. So the thing is, carbon, oxygen, and nitrogen kind of have the same electronic configuration, except for one difference, which is that compared to carbon, oxygen has orbitals which are already full. So it's bonding in exactly the same way. लेकिन वो जो बाकी दो areas है ना, why do you, I mean, why is the shape looking different compared to this one? It's exactly the same shape, except for वो जो बाकी दो orbitals थे ना, उधर electrons पहले से हैं, and they're full. So they're not. हाँ, क्योंकि it's a completely full orbital. Oxygen just has to fill two of its orbitals. The other two are already full. तो वो जो शक्ल है ना, that looks exactly the same, except कि, I mean, they're not involved in bonding. Is that clear?
Yes, sir.
Achha, but anyways, no one is going to ask you about details. Keep this hybridization thing very, very simple. I mean, and the sigma and pi bonding thing very simple as well. They ask you to draw a pi bond. Spot where the double bond is or a triple bond is, that's where the pi bond is. You just draw this thing, that's it. They're not going to ask you how it's happening and all the details. No one is going to ask you about that. Secondly, if they ask you about hybridization, just follow this rule that no pi bonds, that means all single bonds. That's sp3. And we're talking only about these three elements. One pi bond, that's sp2. Focus on the shape. It's got it's going to be trigonal plane. Remember the shape. And if it's two pi bonds, that's sp. And that applies to all three. As a P and Q can be detected in the atmosphere by infrared spectroscopy. Identify two absorptions and the bonds that correspond to these absorptions that will appear. P and Q. What is P and Q? So I've got P and Q. So all you have to do is you just have to look at the difference. Question they're asking. Identify two absorptions and the bonds that that will appear in the of both P and Q. So I don't think I need to even look at the question. I need to look at the data booklet. They both have a C triple bond C. I mean, we would have to look at the data booklet because we're going to tell them about the frequency, the infrared wavelength that's going to be. So that's one, and the C triple bond N that will appear in both. So bas data booklet open karo and just have a look. Where is it? See. So C triple bond C, you'll tell them that there's going to be an absorption at 2150, 2250 in both of them. And there's a CN as well. That's right next door. That's also 2200 to 2550, 2250. So both these absorptions will appear and in both molecules. As a flowchart shows some reactions. Name the type. What is reaction number one? What's the complete name of reaction number one?
Addition polymerization.
Addition.
Okay, so that's addition polymerization. But additions is other important polymerization that it's addition polymerization. What happens when you boil this with H2SO4?
Forms an acid.
Okay, so the CN turns into a carboxylic acid. वो फूल भी लेते हैं ताकि सामने अच्छा this one. So remember, a CN turns into a carboxylic acid if you heat it with H2SO4 or alkaline hydrolysis. So that's this reaction. So it's just going to look like if they ask you to draw this, you'll just have a carboxylic acid at the bottom. That's it, instead of the CN. And it will still remain a polymer. Like nothing happens to the rest of the molecule. The name that's given to this is hydrolysis. Then you've got H2 that's reacting. So name T. What is T? How do you name this?
Nitrile.
Hey, that's not a nitrile. This one is a nitrile. Isko bhi name kar lo balki. What do you call this? The first one. The first one. क्या था?
Propane nitrile. Propene nitrile.
हाँ ठीक है. That's it would have been propane nitrile, but there's a double bond, so the AN changes into EN. उसकी position भी बता दो वैसे.
2.
ठीक है. This carbon would be, I mean, the CN has a higher presence, so it's going to be nitrile. And so it's going to be propene nitrile. The only thing is that you don't have to tell 2 in this case because it's kind of obvious. अच्छा दूसरा बताओ कि वो क्या है?
Which one? T?
T. What is T? They're asking for T.
Propylamine maybe?
ठीक है, that is propylamine. But this one, ठीक है, that's an alkyl chain with an amine. लेकिन I think it's just see IUPAC nomenclature, and let me just go through that once more. I mean, it is propylamine. I'll just Google it. It's I mean, if I Google propylamine, the same thing would appear. It's the same thing. Okay, that's CH3, CH2, CH2, and then there's an NH2. So you're getting the same thing, except that's no longer called propylamine. So I'll just let me tell you the updated version of this. It's called aminopropane. 1 second.
So you want to check the mark scheme?
उसमें भी यही होगा. What's the paper?
It's February, March 21.
M21 QP22. 1 second. M21, right?
It was 2021, the year.
ठीक है वही है. So they're going for aminopropane or propanamine, not propylamine anymore. So this one is aminopropane now. I just wanted to check the IUPAC nomenclature if that has been. ठीक है, but I'm pretty sure propylamine is also correct because everywhere propylamine is used. But this one just very quickly. We're gonna go with aminopropane, whatever CAE says. ठीक है, इधर है amines. Okay, so the IUPAC one is going with the, but instead of propyl, it's now propanamine. That's what they're going with. And the position of the amine group, if it's on the second one, it's going to be, so it's just like alcohol. So just like propanol, this is now going to be referred to as propanamine. ठीक है, so just remember this. तो वापस उस पे आ जाते हैं पेपर पे कि अच्छा, so this one is propane and one amine. ठीक है, so refer to alcohols. Think of it as alcohols. Propanol, propanamine. It's the same thing. You have to give the position as well. As moving on, T can be formed by the reaction of CH3CH2Br with ammonia. State the necessary conditions for that. So which reaction is this? This is this one. Okay. When you have a halogenoalkane, all you have to do is, if you want to replace the halogen with ammonia or amine, it's going to be you add NH3 gas plus heat in a seal tube, or a reflux with the ethanolic NH3. That's what you're going to do. So this is what the condition is over here. You want to get rid of the Br and put an NH2 in its place. So it's let's go with ethanolic NH3 and reflux. अच्छा, फिर आखिरी क्वेश्चन के बॉन्ड एंगल्स बता दो. What's the bond angle over here and over here? X, what is X?
109.5.
109.5. This is tetrahedral. It's carbon. It's इसकी जो actual shape है, that looks like this. ठीक है, it's 3 dimensions. That's 109.5, and this is.
So 90 किसमें होता है?
90 तो होता था बहुत, वो सारे वैसे go through कर लेते हैं. Just a second. ये है ना, shapes होंगी यहाँ पे. एक second. SF6 में 90 होता था when you had 6 bonds. This one. And square planar was 90 as well. Bipyramidal, trigonal bipyramidal was also 90. Just a second. So they go through कर लेते हैं कि 3 bonds, that's 120, right? And 2 lone pairs, 1 lone pair with 2 bonds, that's also the same shape, except the angle is slightly less than 120 because of the greater lone pair repulsion. So you have 4 electron densities. Agar the 4 bonds, that's tetrahedral. If you have 3 bonds, the shape is the same if you have 1 lone pair with it. And if you have 2 lone pairs and 2 bonds, again, it's kind of the same shape, except the lone pairs are not counted as shape. So shape के नाम change होते जा रहे हैं, ठीक है? So 90 was this one, trigonal bipyramidal, when you have 5 bonds. When you had a fan in the middle and 1 bond on top, जिससे वो fan hang कर रहा है, and 1 bond hanging from the bottom of the fan. So that was, they had 2 angles, 120 and 90. ये वाले not important लिखे हुए, they've never been asked, so ignore those. 6 bonds, again, the first one and the last one is important. 6 bonds, it's all 90. It's octahedral. And there's another version which is 4 bonds with 2 lone pairs, so that's square planar. ठीक है, so make sure you remember these shapes. So let's go जल्दी से खत्म करें, wrap up करें. You've got hydroxyethanol reacts separately with 2,4-D pH and with tolerance state. What do you would observe? So 2,4-D pH, will it react or not?
It will react because it has a carbonyl group.
ठीक है, and what would be the observation?
Orange precipitate.
ठीक है, so 2,4-D pH is a test for identifying carbonyl aldehydes and ketones. So what about tolerance? Will it react with tolerance?
Yes, because it's aldehyde.
Okay, so it's an aldehyde, so it will get oxidized by tolerance. What is the observation with tolerance?
Silver mirror.
Okay, so that's going to be silver mirror. Okay, तो ये उसमें देख भी लें कि remember कि primary alcohols that turn into aldehydes, aldehydes can be oxidized, and they can be oxidized by tolerance, Felling, or K2Cr27 or KMNO4, and they turn into carboxylic acid. Ketones, agar secondary alcohol that turns into ketone, ketones don't get oxidized. But both of them, they react with 2,4-DNPH to give an orange precipitate. So this is this one, and वो भी देख लिए.
Sir,
हाँ जी.
would alcohol also react with 2,4-D and pH because it also has a carbonyl group?
नहीं, alcohol does not have a carbonyl group. कौन सा alcohol? इस केस में?
Yep.
हाँ, लेकिन इस केस में इसका सिर्फ ये वाला पार्ट रिएक्ट कर रहा है with 2,4-DNPH, this part. ठीक है?
And what about carboxyl?
नहीं, carboxyl group तो नहीं, this is an alcohol hydroxyl group है.
No, I'm talking like generally if it's carboxyl.
नहीं, carboxylic acid का you have no reactions with 2,4-DNPH. I mean 2,4-DNPH is only this. सिर्फ और सिर्फ ना 2,4-DNPH is aldehyde and ketones, that's it.
Oh, only.
मतलब वो C double bond होगी वजह से नहीं, मतलब it's only aldehyde and ketones, that's it.
Oh.
अच्छा, फिर ये कि ethanol is converted to ethane dioic acid when it's treated with Cr2. What does Cr2O7 do? What is its role?
It's oxidizing agent.
ठीक है, stay and explain the necessary condition for this reaction to be successful. तो वो क्या कह रहा है कि इसको ना दोनों sides carboxylic acid, ठीक है? I mean this turns into this side turns into C double bond O and OH, and that other side also turns into C double bond O and OH. So both sides return into carb. So what are the necessary conditions? Cr2O7 तो पता लग गया. What are the conditions?
Heat under reflux.
ठीक है, और reflux करना है.
Ethanolic maybe?
नहीं, ethanolic बस heat under reflux है. The reason why they ask for the condition is you want the reaction to complete till the carboxylic acid. Whenever the reaction will stop at aldehydes, right? So to complete it, you should reflux it. Nothing should get out. Because if you distill it, then the aldehyde will escape and it will not get converted into carboxylic acid because aldehyde has a lower boiling point. It doesn't form hydrogen bonds, so it quickly gets evaporated from the solution. So it won't form carboxylic acid, it would leave the container. So it's reflux, heat with reflux. Explain भी करने को कहा है, वो खोली हुई थी मार्क स्कीम. Explain में वही होगा वैसे कि sometimes they do ask for this, but over here इसका देख लेते हैं कि ठीक है, बस the second mark is heat and reflux to allow full oxidation. So no detail, I mean no further details, just for the complete reaction so that the alcohol turns into carboxylic acid. So बाकी क्या है कि ये वाला जल्दी से कर लेते हैं. What's use H to represent a hydrogen atom from the reducing agent. So this is aldehyde getting reduced. This is this part. Can't give a chart. So I've got an aldehyde, and the aldehyde could be reduced by NaBH4 or LiNH4. So this one is reduction. ठीक है, this part aldehyde वापस उसमें जा रहा है. So that's reduction. So write an equation for this. So I've got CH2, which ठीक है, this one, and CHO. Okay, the reducing agent must be represented by H. Fine. And
So can you write the reducing agent on the arrow?
That's. But they're asking कि it's represented by H, right? उससे बल्कि क्या अगले step में what's the reducing agent? That's NaBH4.
So you can't write it above the arrow?
करने को नहीं कहा, उसने खुद कहा, इंस्ट्रक्शन दी हुई, use H to represent an atom of hydrogen from the reducing
okay.
agent. So it's forming CH2 OH twice. So how many H's are getting added? That's O to barabar hai, that's 3, 4, and now you have 6. So there are 2 H's that are getting added. So that's it. CH2OH also forms an alkene. A reacts with forms when an alkene A, I mean this one, reacts with. So what alkene will react with cold dilute KMnO4 to give you this? Look, कौन सा alkene है which gets, ठीक है, that's simply ethene. That's a diol that's forming. ठीक है, when alkenes undergo mild oxidation, they end up forming diols. You will have OH on both the carbon atoms. ठीक है, so that is mild oxidation. Cold dilute acidified KMnO4. चलो ठीक है, ये हो गया. कोई क्वेश्चन नहीं है किसी का?
No, sir.
चले, कल फिर कंटिन्यू करते हैं. These Zoha just as tolerance gives both things. It forms a silver metal plus a black precipitate. ठीक है, चले कल कंटिन्यू करते हैं. ओके, अल्लाह हाफिज.
Rufus.
Okay, sir. Allah Hafiz.